Hello. We're going to continue with 3.5, still using z-scores. Z-scores uses a chart in your textbook from page 398 to 399. Today's date, Monday, January the 11th. Okay, so we know that we're going to determine, or well, we probably don't, but that's okay. To determine the proportion, so that's percent, of the population that is represented by a z-score. So we know that z-scores can be any value that is a multiplier of the standard deviation. So when we say that our z-score is not a decimal, it means it doesn't directly correspond with these numbers. Okay, so I'll explain that more when I get there. We're going to identify the range of a z-score. We're going to identify the z-score of an outlier. We're going to identify the z-score of the mean and determine the percentile that is represented by a z-score. Okay, so note number one. We use z-scores to determine proportions, percentages, that are not represented by 67, 95, and 99.7%. So what does that mean? Well, we know that a z-score of 67% is exactly plus or minus 1 standard deviation. So the z-score is this value here. Okay? And for 95, we know it's plus or minus 2 standard deviations. So the z-score is here. And if it's 99.7% of the population, it's got a z-score of plus or minus 3 standard deviations. So our z-score is the number of groups of standard deviations away from the mean, and when it is exactly 1, 2, or 3, or negative 1, 2, or 3, it represents a proportion. So these numbers in front of the standard deviations are z-scores, and these are the proportions. Okay? So z-scores range from negative 2.99 to 2.99. The scores that are less than negative 2.99 are outliers, and they represent 0% of the population. Z-scores greater than 2.99 are outliers and represent 100% of the population. The mean has a z-score of 0.5 equals 50% of the population, and z-scores times 100% is equal to the percentile. Okay, so we're going to be using that formula in a little bit. Okay, so we already said, just really quickly, that a z-score is how far away it is from the mean. Okay, so if a z-score is negative 2.99 standard deviations, okay, it's called an outlier. Okay, so these are z-scores. The value here is the z-score. Okay, and if it is a z-score of 2.99 standard deviations, the z-score is the number in front of the standard deviations, it's also called an outlier. So any value that's out here, okay? And we'd have scores that would match the z-score. So we'd have like a data point. So the outlier is a data point. So over here, an outlier is a data point. Okay, so given the z-score, determine the proportion that is represented and the percentile. So what proportion is represented and what percentile is represented? Okay, so if I have a z-score of 0.53, I need page 398 to 399 to do this question, okay? All right. So if I have a z-score of 0.53, I'll look on the pages that I've already referenced. 0.53 are z-scores. They're in the blue. Okay, so 0.5 is here, but 0.53 is, adding, move this over a little bit, adding these two, a column and a row. So if you add these two blue numbers, you get 0.53. So you get a proportion of 0.7019. And you can see up here, they show you in the textbook that the proportion which has a z-score that is less than or equal to a specific z-score, so our z-score is 0.53, is equal to the answer which matches this number here for us. Now you could look this up, a z-score of negative 1.15, and find that the black number would match the 0.1251. So you can do that, okay? And then they show you when the z-score is negative 1.15, then it is the proportion that's in purple, okay? So you can read this and you can do this question. This is the answer in the chart in the black numbers, and they should be something that you understand, okay? So back to our question, 0.53 is the column and the row added together. So the proportion is 0.7019. Just checking it again. $7019. Okay. So that is their proportion. Okay. If I want to change it to percentile, the z-score times the percent is the percentile. So times 100% to give me 70.19%. That's the percentile. But we don't use the percentage there. We just say we round it to 70 if percentile. Okay, so we really don't use the percentage at the same time that we use percentile. So I will do this. So you get your percent, and then you drop the word percent, and you replace it with the word percentile. That's more clear. Okay. So a z-score of negative 2.1. Z-scores are always in the blue. Negative 2.1. Now this is negative 2.1. There's no second decimal place in our question. So it will have to be negative 2.1 added to 0.00, which is the proportion of 0.0179. 0.179. Okay, so that's the proportion. We want to multiply it by 100%. Okay, so that's the percent. And then we change the percent to a rounded number, round it to the nearest whole number. So that's the second percentile. So we take the percentage and we replace it with the word percentile. Okay? So that means that only 2% of the population would be heavier or or taller. Okay, so it's percentiles are ones that you would have encountered in the doctor's office. Okay, so find the z-score that corresponds to each percentile. So we know it's a percentile because it has the little th. Okay, so the 97th percentile is equal to 97%. Okay, so you take the th and you replace it with percentage, but then you have to divide it by 100% to get it as a decimal. So 0.97. Okay, that number there is what you look up in the textbook. Okay, so 0.97 is the one you see here. Okay, you're going to try to find 0.97. Okay, so 0.97, 0.96, 0.96, 0.96, 0.9. Okay, so 0.9699 or 0.97. So you have to decide which of these two are closer to 0.97. Okay, so 0.97 is somewhere between these two. So you have a choice. You can say it's closest to 0.9699 or it's closer to 0.9706. So you want to find the difference. So you take your 0.97 minus 0.9699. What's the difference? That's scientific notation. It means move the decimal 4 places to the left. So 0.0001. Okay, so that's pretty small of a difference. Or you could do this in your head. You don't have to do the calculator if you can do it in your head. 0.97 minus this number here, 0.9706. We know that this number is larger, so I'm going to give me a negative number, but it's not going to matter anything. So negative 0.0006. Okay, now you have to be willing to ignore the negative signs, okay? And you're supposed to just look at what number is smaller. Well, the difference of 0.0001 is smaller than the difference of 0.0006. So because this difference is smaller, you're going to pick this number here. Okay? So that's smaller. So because it's smaller, then you're going to use this number and read up and across to find what the z-scores are. So these are z-scores. Okay? So I might want to do this because I don't want to keep looking for it every single time. So 0.9. Right? So there's my number. So then I look up. Got to move this over. There we go. There's my number. So I have to look up to 0.8 and I have to look across to 1.8. So you have to look up and across. You have to add them together. So 1.8 plus 0.08 is 1.88. Okay? So if that's your proportion you have to look up in the textbook. Okay, so that number you have to look up in the textbook. All right, so your fifth percent. Now, if you're confused, you're going to stop the video, replay this instruction, and try it on your own. Next one. So we want to find the z-score that corresponds to each percentile. So, fifth percentile is 5% divided by 100%. Okay, so the percent is replacing the th. So 0.05. So that's not a z-score, that's the proportion. Okay, so you have to look it up in the chart. That's my timer. I'm going to stop here, and I'm going to come back with the next portion of the video.